Hello, welcome back to Learn Physics. In today's video, we are continuing with the waves portion. Okay, this is for class 11 students. So here this is the last theory portion of this chapter. Okay, after that we will do the numericals. Okay, so here in this waves, in last video we did tell the nodes, antinodes, positions, isn't it? So here next we are going to study about beats. What is meant by beats? Beats means if two waves of nearly equal amplitude and angular frequency. We are considering two waves having equal amplitude or nearly equal amplitude and angular frequency, nearly equal angular frequency, superpose each other. We will get a wave. So while superposing, we will get another wave. Along with that wave, we can hear something else also. Okay, so see, while tuning the musical instruments, what the musicians are doing, see, while they will tune it, since they are not getting, till they are not getting an extra note, isn't it, or extra frequency. If they are tuning for one particular wave or particular note, see, along with that vibration, we can feel. If those who don't know about the music, we can feel extra musical, extra sound, or like that one bar sound or something, like an extra wave will be coming along with that. Okay, so that extra wave which is coming, that is called a beat. Okay, so when two waves of nearly equal amplitude and angular frequency superpose each other, we will get a wave, an extra wave. That is called a superposed wave will be there. Along with that, an extra wave which is obtaining is called as beat. Okay, so to reduce the beat frequency, that only the tuning means they are trying to reduce the beat frequency. Okay, so here I am considering two waves. Y1 equals A cos omega 1t and Y2 equals, I am considering two waves having same amplitude. So A cos omega 2t. Superposing means y is equal to y1 plus y2, that is A into cos of omega 1t plus cos of omega 2t. Cos A plus cos B. What is cos A plus cos B? Cos A plus cos B equals cos A plus B by 2 cos A minus B by 2. 2 cos A plus B by 2 cos A minus B by 2. Okay. So here while we are calculating this one, we will get it as y equals 2A cos A plus B by 2 omega 1 plus omega 2 into t divided by 2 into cos omega 1 minus omega 2 into t divided by 2. Here we are considering omega 1 plus omega 2 as by 2 as A and omega 1 minus omega 2 by 2 as B. Okay, then we can write it, or I am writing it as omega A and omega B. Okay, then y is equal to 2A cos omega AT and cos omega BT. Okay, so this difference in frequency, omega 1 minus omega 2, this is called as beat frequency, angular beat, or we can write it as nu1 minus nu2. The frequency difference which is obtaining in this frequency, in this angular frequency, that is called as beat frequency. So extra frequency along with the superposed wave, which we are getting it as another extra frequency wave, that is called a beat frequency. Okay, so we are trying to reduce that cos omega 1 minus omega 1 minus omega 2, how much it is reducing, that will be good. So beat frequency will be very, very less. So nu 1 minus nu 2, that will be called as the beat frequency. Okay, so understood. So beats means the two waves which are having nearly equal amplitude and frequency superpose each other, we will be getting a beat, an extra frequency, that is called a beat frequency or beat. Beat means the regular waxing and waning of sound, waxing and increasing and decreasing. Okay, waxing and waning of sound will be giving, so along with the tuned frequency, superimposed wave, along with that we will be getting some other sounds also, some other waves also, that is called a beat. Okay, so clear, understood how we are finding out the beat frequency? Okay, nu 1 minus nu 2, that is called as beat frequency. Okay, clear? So next we are going to study about Doppler effect. Okay, next is Doppler effect. Doppler effect in sound. Okay, suppose the teacher is talking from the near to the board. Okay, see, I am standing here. The child who is sitting at the back bench of the class, see, suppose 10 rows of 10 rows of benches are there, and the child who is sitting at the back bench, whether the sound which he receives will be the same as that of the sound received by the student who is sitting at the front bench? No, isn't it? So as distance increases, the frequency of the wave also will be decreasing. Or as the distance decreases, frequency also will be increasing. Okay, so when I am saying this, here who is producing the sound? They are called as source. Okay, so here source means they are producing the sound. Next is listener or observer. Listener or observer is who is listening the sound. They are called as observing the sound or listening the sound. So that is listener. So the distance between the source and listener varies. According to that, the frequency also will be varying. The actual frequency of the source won't be reaching to the observer because if the distance increases or decreases. Here, that means here there is a relative motion. If there is a relative motion between the source and the listener, if there is a relative motion between the source and the listener, then the frequency of the sound wave will be varying. Okay, so that means, see, some announcement is going on. Suppose some announcement is going on. We are here in the class. When the announcement is next near to our class, we can hear it very clearly. So when the announcement is moving, that is, it is passing by, that time the frequency also will be decreasing, isn't it? So that means that here in that case which I explained here, the observer, we are the observer, we are at rest, but the source which is producing the sound wave, they are moving. Okay, observer is stationary or listener is stationary, the source is moving. Okay, so here we are going to study about the first case. So when there is a relative motion between the source and the listener, observer or listener, the frequency will be changing. How the frequency will be changing, that one we are going to study in different cases. In case 1, if the observer at rest, that is stationary, and the source is moving. Source is moving and observer is stationary. So observer is stationary, right? So I am drawing the observer here. This is the point of the observer. This is the point of the source. Okay, so this observer and source are at distance L. Okay, V is the velocity of the medium. Velocity of the sound wave to travel while the sound wave is traveling in this medium, V be the velocity. Okay, so suppose the source S1, the position S1 I am marking S1. At the position S1, it is producing the first crest. Okay, first crest it is moving. So first crest, how long it will take to reach the position O? So it is at this distance, it is the wave is moving with the velocity v, and after traveling a distance of L with the v speed, it is reaching to the observer. So what is the time? Distance is given, velocity is given. Time for the first crest, time required is, what is the velocity equals distance, speed equals distance traveled divided by time. So time equals distance traveled divided by velocity. Now it is moving. It is reaching to the position S2. So it is producing the second crest. So this distance is called what will be this distance? It is moving with the velocity. Source is moving with the velocity Vs. So what will be the distance covered by this source? Okay. So the time required as Vs is the velocity of the source, or speed of source is Vs. First crest is producing at S1 and the second crest is producing at S2. So the distance, the time required for the first crest to second crest. So the time is the period. So T0 is the period for the traveling from S1 to S2. Okay, period of the wave. First crest is producing at S1, second crest is producing at S2. So the period, time required for one wave to travel, that is period. So that is T0. So what will be the distance covered? So T0 is the period of wave, because time required for between the first crest and the second crest. So that is period. Vs is the velocity of the speed of source. So distance traveled by source is, how we can find out distance traveled? Distance traveled equals velocity into time. Okay, so now this much time it had taken. So the second crest, when it will be reaching to the observer here, second crest, observer. Okay, this is first crest to the observer, time required for the second crest to the observer. So first crest will be reaching by L by V. Second crest, should travel from here to here. For that, how long it will take? T0 time it will take. Isn't it? From there, it will be traveling this much distance. So what is this distance is L. This distance is Vs into T0. Okay, so the second crest will be taking the time T, time required for the second crest. How we can find out? That will be T0 plus, next is time required. Time, how we can find out? Distance traveled divided by velocity. Distance traveled is L plus Vs into T0 divided by V. Right? Clear? So first crest started from here, reached here in the observer. Now the second crest for traveling from S1 to S2, it took Vs into T0 distance. It covered Vs into T0 distance. For that it took time T0. Okay, and from here to here it should travel. For that, how much distance it has covered? Vs into T0 plus L. So L plus Vs into T0 divided by V. Okay, this is for the second crest. T2 equals T0 into N plus Vs. So if this is the case, for reaching N plus 1 the crest to the observer, how long it will be taking? Time required as N for second crest T0 plus LVS into T0 by V. Same way, N second crest means here and on 1. So here it is N plus 1 the crest means N T0 plus L plus Vs into N T0 divided by V. This will be the time required for the N plus 1 the crest to reach to the observer. Okay, now we are finding out what is the time required for the N crest to travel? N plus 1 crest at this much of time, 1 crest L by V. So time required for N crests, time required equals N plus 1 minus first crest, isn't it? So N T0 plus L plus Vs N T0 by V minus first crest L by V. So here what we will be getting, rest of the things I will write over here. Here L by V minus L by V, that will cancel. So here we will get it as T equals N T0 plus Vs N T0 by V. So for N crest this is the time. For one crest, what will be the time required? T is equal to N, instead of one crest means divided by N. So the N, this is the time required for N crest. So here for one crest means it will be T0 plus Vs T0 divided by V. How we are getting? Tn divided by N. Okay, so here we are getting like this. This one we can write it as T0 into Vs by V. So or we can write in terms of frequency as nu equals T equals 1 by nu, or nu equals 1 by T. So 1 by T is nu equals 1 by T0 is nu 0, 1 plus Vs by V the whole power minus 1. Okay, nu is equal to nu 0 into 1 plus x the whole power n. In another video I did this. N equals 1 plus nx plus n into n minus 1 divided by 1 into 2x square plus etc. Like that it will go, but higher powers we won't consider. So we can write 1 plus nx. So here 1 plus n is minus 1 minus Vs by V. This is, so here this was the position of observer and this was the position of source. Okay, S1 and this is S2. And this distance was L and it is moving with velocity V, and so here it is Vs into T0. Okay, this was that. So here source, in which direction it is moving? Source is moving away from the observer. If source is moving away from the observer, this will be the frequency. So suppose if source is approaching the observer, what will be the case? If source is approaching the observer, nu equals nu 0 into 1 plus Vs by V it will be. Okay, that one, this derivation is not required. Rest of the things I am not giving you the derivation. So this one just for understanding. So in most of the schools they won't teach this derivations. If you don't want that derivation, just neglect it. But understand the way how we are approaching to the final equation. Understand the concept. Okay, and the final equation also. Okay, nu equals nu 0 into 1 minus Vs by V. This is the frequency. This is the apparent frequency. That is not the actual frequency we are, the observer is hearing. Okay, when the source is moving away from the observer, and when the source is approaching the observer, it will be nu equals nu 0 into 1 plus Vs by V. Okay, clear? So these are the rest of the formulas, that the source is moving and observer is at rest, we learned like this, and now observer is moving and source is at rest, we learned like this. So it is nu 0 into 1 plus Vo by V. Okay, 1 plus VO by V, and both source and observer is moving. So this condition, if you know, you can write down the rest of the things. Okay, so that is, we will always consider observer to source as positive. Okay, so here if both source and observer is moving, suppose if source is at rest, Vs is 0, source is at rest. Okay, Vs is equal to 0. Now, how the equation will be, nu equals mu 0 into 1 plus Vo by V. Like that it will change. So, suppose observer is at rest, what will happen? So, nu equals mu 0 into V divided by V plus Vs. Okay, so V divided by V plus Vs, that will be the mu 0 equation. So like that, if as the source and observer is changing or not, like that we can understand. So if you are finding out this equation alone, then also you can find out the answer. Okay, that is not a different thing. That is V plus, you are wondering why the difference, because V plus Vs by V, the whole power. So here this one we can write it as V plus Vs by V, the whole power minus 1. So 1 plus Vs by V, the whole power minus 1, that is 1 minus Vs by V. This is what we are getting over here. So don't get panic whether we are getting it or not. So it is correct only. So here we are writing it, nu equals, only this equation if you are learning, you can write down everything. You should consider object is moving towards the source, means it is positive. That one you can consider. The rest of the things will be the opposite direction, means it is negative. Object towards the source. Object should move towards the source, then it is positive. The rest of the things negative. Okay, clear? So if you are studying only this equation, according to the source or observer, if it is at rest, according to that, if you are changing the value, and positive and negative sign also you should change, because observer towards the source is positive. In that way you should do. Okay, so I think it is clear for you, and in next video I will be coming with the rest of the numerical in your textbook. Okay, so I hope it is clear, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.